So the problem at hand is to solve a trigonometric equation sine 3x equals root of 3 over 2 for the domain of x being greater than or equal to 0 and less than 2 pi. So we want to be able to look at the unit circle, and the unit circle is in terms of sine of x, cosine of x, tangent of x, not sine of 3x. So let's do a substitution so that we can refer back to the unit circle. So let u equal 3x. And this concept of substitution in mathematics is extremely powerful because you can take a more complicated problem and make it a little bit simpler using substitution. So if we let u equal 3x, what that does to the domain, I'm going to write it like this for now so you can see it, is that I'm going to multiply everything by 3 because I'm letting u equal 3x. So this is 0 less than or equal to x less than 6 pi. So that's the constraint that goes along with u when we let u equal 3x. So now we can look at the unit circle. So now we're going to be working with sine of u, and we can go directly to the unit circle, which is helpful because now what I'm looking for on the unit circle is where does sine of u equal the root of 3 over 2. So let's find all of those places where that is true. And if you think of the unit circle, it happens in the first and the second quadrant because your y is positive in the first and second quadrant. So this happens at, well, before I do that, remember that sine of u is equal to y over r. And the question boils down to then where does, and r is equal to 1 on the unit circle, so where does y equal the root of 3 over 2? And that happens at u equals pi over 3, right, in the first quadrant, like I said. And it also happens in the second quadrant because your y component is positive there too, right? Your y coordinate. So it happens at pi over 3, and in the second quadrant it happens at 2 pi over 3. And remember, this is u now that we're working with. So u is equal to pi over 3 and 2 pi over 3. And then it repeats itself. Since our range allows us to go to 6 pi, right, and you're on the unit circle, I'm just going to draw a rough unit circle here. And here we go. All right, this is roughly the angle of pi over 3, and this is 2 pi over 3. So and this is, the unit circle goes from 0 to 2 pi, right? So if I can go 6 pi, that means 3 full rotations. So let's do that. So let's go a full 2 pi around from this point, and I get back there. So if I add 2 pi to both of these, I get the next set, right? Because I can also grab another color. I can also go a full 2 pi and get back to here, right? So if I add 2 pi, and 2 pi in fraction form, so that I can just simply add the fractions, is 6 pi over 3. So that's equal to 6 pi over 3. And this is the same thing, right? So if I add 6 pi over 3 and pi over 3, I get the next set. And the same thing here, 6 pi over 3 to 2 pi over 3. I get the next set of solutions, which would be 7 pi over 3 and 8 pi over 3. Well, we're not done yet because that's 4 pi, if you will. We can go another rotation. So let me grab another color. And from this point, we're going to go again. So now I'm going to take this and add 2 pi as well as this. Right? And again, you're adding 6 pi over 3. So my last 2 points would be 13 pi over 3. And your very last one is 14 pi over 3. Sorry, I didn't have the room there. Okay, so what we end up with is u is equal to pi over 3, 2 pi over 3. Just going to rewrite all the solutions so we can manipulate them. 7 pi over 3, 8 pi over 3, 13 pi over 3, and 14 pi over 3. So they're your solutions for u. But the original problem was in terms of x. So we know that u is equal to 3x, so solve for x. And we have x is equal to u over 3. And I want the solutions for x where that equation sine of 3x equals square root of 3 over 2. So I need to divide all of these by 3. So x is equal to u over 3. So I divide pi over 3 by 3. Okay. All that I did over here was pi over 3 divided by 3, which is equal to pi over 3 times 3, which is equal to pi over 9. So your first solution here is pi over 9, like that. And in fact, you're going to divide each and every one of these, right, by 3. So your second solution would be 2 pi over 9, and your third, 7 pi over 9, and your fourth would be 8 pi over 9, and finish it out, 13 pi over 9, and 14 pi over 9. And that's your solutions on the range from x equals 0 to 2 pi for this trigonometric equation.